Isaac Newton, born on December 25, 1642, died in March 1726. He was an English physicist and mathematician and is one of the most influential scientists of our time. His book, Mathematical Principles of Natural Philosophy, which was published in 1687, laid the foundation for classical mechanics. He aided the development of calculus, and his publications formulated the laws of motion and of universal gravitation. Newton's first law, the law of inertia, says that an object in motion or at rest will remain that way unless an unbalanced force acts upon it. The law is better explained using Newton's cradle. Before letting one of the balls swing, it had only been experiencing vertical acceleration. The addition of horizontal motion has resulted in additional force. One ball collides with the others, causing unbalanced force on the opposite extreme. The balls will continue this opposing motion until friction and air resistance cancel out kinetic energy in the circuit. Before letting one of the balls swing, it had only been experiencing vertical acceleration. The addition of horizontal motion has resulted in additional force. The acceleration of an object is dependent upon two variables, the net force acting upon it and the mass of the object. As the force acting upon an object is increased, the acceleration of the object is increased. As the mass of an object is increased, the acceleration of an object is decreased.
In this experiment, Alexis was pulled by two different objects falling from the top of a balcony. The first object was a concrete brick with a mass of 1.5 kilos, and the second object was a haystack with a mass of 4 kilos. You might be wondering, how do you calculate the gravity of force? In this experiment, we will be explaining three different types of forces. The first one, which was explained before, it's the gravity force, represented by the two objects while they were flying off the balcony. The second type is the friction force, which will be represented by Alexis and his skateboard. The friction force is the force exerted by the surface as an object moves across it. In this experiment, the friction force would be considered sliding force because Alexis moves across the floor. As he is pulled across the hallway, the two surfaces, his skateboard and the floor, are pressed together. On the third force, even though Alexis is being pulled by a relatively heavy object, his acceleration is not as high as we expected. It is not 9.8 meters per second squared. Alexis weighs approximately 60 kilograms. If the person pulled had been smaller, the acceleration would have been greater. The greater the mass, the less acceleration. Because Alexis is pulled by objects with an acceleration of 9.8 meters per second squared, the person watching the experiment would think that Alexis' acceleration is 9.8 meters per second squared, but it's not. Both the objects and Alexis are accelerating in different directions. Alexis' acceleration is going rightwards, with no influence of air resistance. Therefore, the acceleration is not constant. Alexis' velocity is not 9.8 meters per second, across the hallway as it was predicted. Otherwise, he would have reached the border of the balcony within less than 1 second, which he didn't. It actually took him over the second, meaning that his velocity was less than 9.8 meters per second. The net force is represented in the person's velocity. To calculate the net force, we would need to know Alexis' acceleration, but because it's not constant, we can't calculate the net force even if we have the mass. We could also see this experiment from another perspective. Both the gravity force and the friction force interact with each other, and the middle point of this interaction is Alexis while moving across the floor. Alexis would represent the net force of this experiment, therefore the velocity. In this particular case, the velocity can't be 9.8 meters per second. Otherwise, we would watch Alexis moving faster than he actually is. The friction force works as a holder for the gravity force. Therefore, instead of moving at a velocity of 9.8 meters per second, he's moving slower due to the friction the skateboard has against the ground.
Newton's third law states that for every action, there is an equal and opposite reaction. In the case of a trampoline, a body is freely suspended in a space and is not in contact with anything else. In this case, the action and the reaction have to do between two different but connected parts of the same body. When you push down onto the trampoline, Newton's third law says that an equal and opposite reaction pushes back. This is where you get the bounce. When you exert force on the springs, causing them to extend, then you have an equal and opposite reaction coming from the springs themselves. The springs push back with the same force that you exerted, and then you're sent flying into the air.